think you can start. Well, first of all, thank you everyone for watching us today. So the idea here is to present a practical guide for how we can design, build, and deploy REST-based microservices using the Sensedia ecosystem behind the scenes. So with me, I have Gabriel. Let's present myself first. I am Filipe Torqueto, lead software architect here in Sensedia.
So I'm Gabriel Zessin. I'm a software architect here at Sensedia as well. Thanks everyone for joining.
So our schedule today basically is showing how we can design our microservices, of course, using an API first approach within our API platform. How we can expose after the design of the APIs and after everything started, how we can expose those backends and those services, join with the API strategy within our service mesh products and how things are built together. How we can do security, and of course, how we decouple the non-functional requirements. One of those and the most important one is security. How we are building the security perspective within the microservices using our platform. How we are building our API security on top of it, how we can onboard new developers and new partners to consume our APIs in a secure way. And of course, the last part of this presentation will be a live demo on everything working together within some samples of microservices running. So just a context to set our scenes. The main business and the main objective of the business and the main objective of our company is to keep our customers focused on their business. So moving the part of the technology perspective and the non-functional requirements, security, so on and so forth, to be built on top of our platforms in order to facilitate and to gain speed on the development perspective for APIs and microservices. So first, we have capabilities to standardize security within the flow of East and West and North and South, meaning that we can standardize security in the API border. So external consumers, everybody that will consume the API from an external world, we are doing the security standardization and we are doing the security capabilities. And of course, how we can build and how we can start build a zero trust security using our service mesh and using the authentication and authorization all together with our API gateway and our service mesh working together to standardize the security since the development until the exposure of the API, of the finished API. How we can adapt and how we can build microservice archetypes using our product and how we can facilitate the development and how we can help the developers to keep themselves focused on the business development itself. Deployment standards, we have capabilities out of the box for the deployment modes like canary releases, how we can build canary releases in an easy way using our products, how we can deliver the deployment since the backend throughout the API, how we can do a standard and secure way of versioning our backends and our APIs all together. And the last part will be the observability standards, meaning that we want a solid and distributed architecture. We know that. Although we have concerns like observability concerns, so how we can retrieve logs, how we can see when something goes bad, and how we can actually prepare ourselves if something goes bad in the architecture itself. Let's start with the API first and API design first, like we name it in Sensedia. So we have in our API platform, and the demo will show you guys a little bit, we have a full capability of designing the API at the beginning of the process. So we can help business guys and we can help API product owners, business developers, so on and so forth. So we will helping them to actually start by the design of the API since the beginning of the development process. And we can provide them, for example, mocking perspectives, advanced mocking perspectives inside the platform to provide them a quick view of the API and a quick view on what exactly the API will look like at the end of the development process. And of course, at this point, the idea is to accelerate and to show them the capabilities of the APIs before the finished product. So at the moment, we are using the capabilities of our API gateway, our API designing, to provide them a capability out of the box to show to some customers, to provide them an MVP perspective or anything like it, to show them the capabilities that what they can do with those APIs at the end of the day. And of course, to provide them a quick feedback from the business stakeholders if it's the right path or not. So we can quick design, go ahead on the testing. So if it fails, we go back to the design and move ahead real fast without the nuances of going back to the backend developers, changing everything, deploying everything all together and moving back and forth. So this is the idea behind the scenes. This is nothing new, but it's a pretty important concept to set the scenes and, of course, and how we can doing it with our API platform. Another important thing to mention here is our API platform comes within our API developer portal. So if the intention is to move fast and provide external API consumer the documentation for them to test your API at the end of the day, we also can do it in the design phase, and provide them a quick documentation, even with mocks, to see if it's adjustable and if everything is okay with the consumer side, and grab the feedback real fast. So this is the idea with this first step of the design. The second part here will be after the design, so we can accelerate the development itself. So okay, the design is made. Everybody's happy with the outcomes of the API, the documentation is ready, so we can move ahead with the development perspective. So we're setting the sprints, we're setting everything up to start the backend. And we don't want that our customers facing issues and facing troubles with no functional requirements and requirements that are not explicitly with their business, meaning that what are the deployment standards, observability patterns, so how we're going to build the observability, routing, service discovery, how exactly we're going to build the service discovery for microservices in the Kubernetes cluster, for example. So those are some of the setbacks, not all of them, of course, but those are some of the setbacks that we're facing during the development phase that will slow us down, basically. And we don't want that non-functional requirements, especially, slowing us down, because we want to be focused on the business and we want to accelerate our customer development perspective. So with our service mesh product, we are going to standardize the deployments and build the deployments out of the box, provide our customer options to different types of deployments without too much difficulty to implement them. And of course, removing this requirement from the development and moving to the infrastructure part and resolving this out of the box with the Sensedia product. We also provide some standards to build an observable microservice, and these observable microservices, after deployed in our platform, in the Kubernetes platform that have the service mesh, Sensedia service mesh running, will be fully observable. So this microservice can be, will export logging, will export metrics, and will have all the capabilities that we need for the distribution or distributed architecture. Routing and service discovery can be tricky, we know that. And also we can provide some toolings out of the box again to help the developers to go ahead and consume other services even within the same company. So this is that's not a functional requirement, but this is a tricky requirement that we can facilitate with our product also.
Torqueto, we are getting a little bit of noise from your microphone, a static kind of noise. I don't know if you can try to.
Better?
Not really. We can hear you. It's just a little bit static, but yeah.
It's better now?
No, not for me. But okay. Yeah, it's better now.
It's better now?
Yeah, it's better now. Okay.
Okay, so sorry about the noise. So moving ahead, and let's take a little deep look in the security perspective. So we have different approaches in different scenarios to apply security. And today, security is very sensitive because the digital products are a target, basically, especially on this new normal post-pandemic world. So we started to talk about zero trust security or zero trust network security. So our service mesh will provide important security features out of the box since the beginning of the development. And of course, again, removing the responsibility from the development part and moving this responsibility to our platform with standardization. And of course, we're ensuring this type of method, depending on the needs, of course. But we can establish authentication and authorization using the OpenID provider that the customer choose. And we also, in a simple clicks and with some certificates, we can add MTLS or TLS encryption even inside our cluster, meaning that even the communication within your services inside your cluster will be secured and encrypted. And of course, authentication and authorization with the ingress gateway, meaning that outside from inside and within the services. So if you want to your service being authenticated and authorized, even for internal users, it's something that you can achieve with our service mesh without any difficulty. So we will provide some details in the demo, of course. But those are some capabilities that we can achieve with the product, meaning that the security with the backend in the distributed scenario, of course. And we will also take a deep dive inside on how we are building our API platform security for a B2B or B2C. In this case, we're going to show the B2B use case for how we can secure MTLS communication for B2B users using our gateway, how we can use OAuth 2 flows, authenticating and authorizing the services for external users, and how we can prevent some attacks like DDoS, JSON injections, and some other common attacks that we're seeing today. Of course, just an overview explanation of how we're going to use our tools and where those tools are sitting. Okay, so essentially, we will have for the external network, meaning that for external users, we will have our API platform in front of it. So every external traffic will reach our platform, will pass through the flow that we are going to configure inside the platform. And after the security perspectives and all the measures that we're including in our platform, we're going to reach the backend where our service mesh will be sitting, managing the traffic throughout the services itself. So this is the general overview of the platform. So dividing the networks on north and south and east and west, just to be clear. North and south meaning the external network for my internal service. East and west meaning that I have a service A calling the service B inside my own network. Okay, and some of the capabilities, of course, that we can achieve is security by the both sides. So we are making the security for external users using our API platform, and we are doing a security approach on our backends using our service mesh. And of course, we have traffic management, observability, network abstractions, and other use cases that we are going to show for you guys in the demo in a few minutes. This is the use case of the demo. So essentially, like I said, we have external consumers reaching our API gateway. And we have a Kubernetes cluster running with our service mesh on top of it. And our API gateway is making the communication with the backend using a secure channel, using, in this case, MTLS. So we are using MTLS for the external consumers for the gateway, MTLS for the gateway to the backend, and also MTLS for the communication within the services. So the entire ecosystem is encrypted, authenticated, and authorized. So if you don't have the credentials, or even if you achieve a way to go ahead and reach the flow of data, the data will be encrypted. So everything is secured in every side possible. Okay. So for the demo use case specifically, we have 3 microservices: account service, customer, and payments, all running in the Kubernetes cluster, like I said, and our gateway on top of those 3. And of course, those 3 services are REST-based services, meaning that all the external calls are being made by external API calls, and the services communicate within each other using REST APIs also. So this is a pretty common use case for the market, and this is the showcase that we want to demonstrate for you guys today. So let's go to the demo. Gabriel, want to take place there? So
Yeah, sure.
Stop my sharing. You can start yours.
Okay, I'm just gonna share my screen here. So yeah, basically we're going to talk about, I'm going to try to follow the same steps that we followed during the presentation. So the idea here is to show how Sensedia API platform and our ecosystem can help our customers achieve an API first approach and secure their APIs using our service mesh for east-west, using our API platform, our API gateway for north-south communication. So this is our dev portal, a developer portal that we have for our environment here. So basically, you have here a home screen, but I'm going to show you guys here the API browser screen. So basically, when we're developing an API and we are using an API first approach, what we want to do is we want to show our stakeholders, our consumers, the business stakeholders, we want to give them the API before we manage to develop the code. So your development team is going to develop the code after we collected feedback, for example, from the stakeholders, from the consumers. And then when we get to the development phase, we're going to be more sure that our API is going to fill in the needs that our consumers have, right? So basically here we have a dev portal, and we have 3 APIs here. Basically 1 API for each service that Torqueto has showed in the demo, in the slides. So I'm just going to open these in new tabs here for us. So we have, for example, the customers service, and this is a open API specification that we have developed for this particular service. And as we can see, we could share this documentation with the stakeholders and the consumers, so they could see how the API would look and how the API would behave even before the API is ready, right? So this is for me the great benefit of API first, because you can collect feedbacks more fast from your consumers. So this is our customers API. We have basically 4 operations here. And another cool thing that we have here in our dev portal is we can use, for example, this tryout feature. So our consumers could, for example, try to call our API. Of course, we have a sandbox environment here on the top. So I've selected this sandbox environment. So this request, this tryout request, is not going to reach my backend, right? Because my backend is not ready yet. So I'm just sharing my documentation with my consumers. So my consumer is going to call a sandbox environment, and this sandbox environment is going to return a mock response. And with this mock response, our consumers can manage to see how the response is going to look like and start developing their side of the communication as well, right? So if you perform a tryout operation here, I'm just going to put some random customer ID here. If we execute this, we can see that we get a curl here. So this is where our request is hidden, right? We can see that it is a sandbox environment here. And we have the response that the server has given to us, right? So this is just a basic response of how the API is going to behave. Of course, this is a static response. This is mocked. but the consumer can see how the API is going to behave, right? And this is valid for all the APIs that we have here. So the accounts API as well, we could try it out if some random IDs here. It's also going to respond with a mock. Okay, so how is this mock working, right? Because this is a dev portal. Okay, this is a the documentation of our API, but we are pointing here to a server, right? So this URL is actually pointing to an environment that is configured inside our Sensedia API platform. Okay, so this dev portal is integrated with a Sensedia API platform. Okay, so I'm just going to move to another tab here. So this is the tab. This is the tab of my Sensedia API platform that we are using for this demo. And as we can see, I'm on the API catalog screen, right? And I just filtered for our APIs here from Apidays. And we have the basically 3 APIs here for our services. So we have a payment service API, customer and account service as well. And we also have this OpenID provider API. I'm going to talk a little bit about this API later on, but this basically provides an integration with an OpenID provider. Okay, but the services APIs are basically these 3 APIs. So I'm just going to open them in new tabs so it gets easier for us to navigate. So this is the customer service API. And here at the top of the screen, we have some basic details of the API. So we can see the name, we can see the base path, some description, the responsible. And what's important for us to note here is that we have 2 revisions of this API. Okay, so revision is a concept here in Sensedia API platform that we can separate different behaviors between the revisions of our APIs, right? So this revision 2, we can see down here that it is deployed in the production MTLS environment that we are going to use for our demonstration here. So this is an MTLS environment, as Torqueto mentioned. But we also have the revision 1, which is deployed in the sandbox environment. Okay, so this is the when we make this tryout request here in the documentation in the OpenAPI specification, this request is going to hit Sensedia API gateway, and Sensedia API gateway is going to forward the request, is going to route the request to this API because we have this base path here, so it's going to identify that this request has to be forwarded to this API here. And the sandbox, if this call is to a sandbox environment, then it's going to be forwarded to this revision 1. Okay. So down here, we have the flows. What else we can see here is the operations that we have for this API. So the same operations that we had on our documentation, the 4 operations are here. Okay. And we also have the flows of our API. And this is the cool part because in the flows, we can define how our API is going to behave before the request hits our backend and before the response that our backend sent to us, before this response hits our clients, right? So basically in this screen, this flow screen, we have 2 rows here. This top row is basically the request row. So before the request reaches the backend, anything that I configure here is going to happen, is going to be executed before the request even gets to my backend. And everything that happens here in the bottom row is going to be executed before my request, before my response is sent to my consumer. Okay, so we can see that we have our resources here. So for all resources and all operations, we're going to have basically a log, and these are called interceptors. Okay, so every icon that we have here, we call them interceptors. So this is a log interceptor that is basically going to log everything that happens in my request. So the headers, the request body, for example, is going to be logged. And also my response is going to be logged here. I have a header interception just for course purposes here, but it's not important for us. And if we get to the customers, for example, get customer by ID that we just performed a call in our OpenAPI specification, we can see that after the log interceptor, we have a mock interceptor right here. So you can see here in the top that we have lots of categories for our interceptors. Okay, security, transformation. And this is a traffic interceptor because it's going to return a mock for my consumer. So when the request comes to this flow and the gateway finds a mock interceptor, the gateway is not going to forward the request to the backend because it has found here a mock interceptor. Okay, and basically this mock interceptor, if I click on it, we can see that we are returning a status of 200. Some headers here to say that this is a JSON, and here we have the JSON body. Okay, so basically when I make the request in my OpenAPI specification with the tryout feature, this is the response that I'm going to return. Okay, so we can see how easy it is. This is basically drag and drop. So if we take this mock interceptor here, we can basically drag and drop here on the flow, and we can just fill in up the fields. And there we have our mock already implemented. Okay, and also we have the mocks for the other operations as well. So for example, this get customers returns an array. So this is the array of the that we return. So this is basically how we implement mocks in Sensedia, and we can see how powerful this is because this is fast. This is very fast for us to implement, and our consumers can basically call our APIs even before our backends are ready. Okay. So moving forward, let's move to the next step, which is exposing our backends, right? So as we mentioned in the slides, let me just show this again. This is the architecture that we are using. And we have 3 services here, and these 3 services are deployed in a Kubernetes cluster, and we have a Sensedia service mesh on top of Istio. And Sensedia service mesh with Istio are managing the communications between our services here, and also the communication that comes from the Sensedia API gateway inside the cluster also is managed by Sensedia service mesh. Okay. So I'm just going to move on to the service mesh. So this is the main screen of the service mesh here. So basically, we have here the namespace of our Kubernetes cluster, right? So we are using basically this Sensedia bank namespace. So I'm just going to click on it. And here we can see that we have our services deployed in our cluster. So yeah, we can see the pod quantity, for example. I have 1 pod for account service, 2 pods for customer, 3 pods for payments, right? And of course, you have to deploy your services first, and you have to create your namespace, and you have to inject some Istio labels into your namespace in order for Sensedia Service Mesh and Istio to see your namespace, to configure your namespace. So after you deployed your application, you can move on to the Sensedia Service Mesh, and your namespace is going to be showing here. And what can we configure here, right? So if I take a look at this mesh configuration right here, we can see that we have a host here. So this is basically the URL, the host that we are using for this demo. So every time that my gateway is trying to send requests to my service mesh, it's going to send to this host, right? And we can see that we are using MTLS configurations here. So when we use MTLS or TLS, we have to tell Sensedia Service Mesh which certificate we are going to use. So inside our Kubernetes cluster, we have a secret, which has this name. And inside this secret, we have the TLS certificate and the trust CA for the MTLS handshake to work. Okay, so this is easy. We just have to check this MTLS option and and fill in the secret name with the certificate, and then we already have the MTLS configured for our service mesh. Okay, I'm just going to enter into each of these services as well. So we have the accounts, customer, and payment service, and this inside each service we have some more configurations that we can make, and I'm going to show some of them. So we have here the pods, right? So you can see that the account service has 1 pod, the customer service has 2 pods, and the payment service has 3 pods. And just pay attention to one detail here. We have 2 pods for payment service, which is on the version 1, and we have a payment service which is on a version 2, right? So this is like a new version of my payment service. Okay, so I have 3 pods, but one of them is from a new version that I'm trying to release, for example. Okay, suppose this is a canary release, for example, right? So just showing here what configurations we can make. So we basically have this traffic management tab, and here we can configure how Sensedia Service Mesh is going to forward the requests to our backends, either for external requests or internal requests as well. Okay, so basically what we can see here, if I edit this configuration, we are enabling MTLS here, right? So the communications that come from the external world to my account service are going to be using MTLS, and the internal is using MTLS as well. So I have the name of my service, the port that I use in my services in Kubernetes. I have here the path that I'm going to configure. So basically, every request that comes with a path of /accounts is going to use this routing rule. Okay. And we're basically telling Sensedia Service Mesh here that we are going to split this traffic by weight, but as we only have one version of this service, of course, we can only send traffic to this one version, right? So we are sending 100% of requests to the v1 version of our account service. Okay. So this was the traffic management part. We also have authentication. So as Torqueto mentioned during the slides, every communication that happens between the services and also the communications that happen that come from the external world, that come from Sensedia API Gateway, for example. These requests are using MTLS, as we just saw, but these requests are also using authentication and authorization using an OpenID provider that we have. Okay, so we have an OpenID provider that issues tokens and controls the communications, the security between these services as well. So every API request here is authenticated and authorized. Okay, so here is where we configure the authentication part. And if you take a look at this configuration here, we can basically see that we are basically configuring who is the issuer or who is the OpenID provider that we are using for this communication to be authenticated, right? So I'm basically telling Sensedia that this is the URL of my OpenID provider, of my authorization server. And this is the JOX URI that we are using so Sensedia Service Mesh can use the public certificates of our OpenID provider to validate if the certificates are valid, if they are not expired, if the tokens that we are receiving for these requests are valid, if they were really issued by our OpenID provider here. Okay, so this is why we have this JOX URI here. And basically, we're telling here that every path of /accounts is going to be authenticated. Okay. And we also have the authorization tab. And basically, this is where we configure that our services, that our requests are going to be authorized as well. So if we look at this configuration, we can see that for the paths of /accounts, we are basically telling Sensedia Service Mesh that the roles of our token they have to contain at least this value of accounts. Okay, so if my OpenID provider issues a token and this token does not have the role of accounts inside the token, it means that the user that issued this token does not have the accounts role, so it doesn't have the permission to use this accounts API, for example. Okay, so here we configure the authentication. We can identify who is the user that is calling our API, who is the consumer, right? So we can authenticate the user. We know who the user is, and then with the authorization configuration, we are basically seeing if the user, we're checking if the user has the correct permissions to perform that operation. Okay, so basically for accounts, we have a role of accounts. For our customer service, this is going to be the same thing. I'm not going to dive into the same things here because the configurations are basically the same. But just to show the authorization part of the customers, we have the customers role here. Okay, and for the payment service, we have the payments role here. Okay, and for the payment service, remember that I mentioned that we have a v2 version here. So just to show the traffic management of payment service, we can see that we have both external and internal traffic managements configured. But if you take a look at the external, for example, we can see that we are using MTLS, the port here is configured, but we are splitting our traffic between two destinations here. So I'm basically telling Sensedia Service Mesh that 70% of the requests are going to be forwarded to the v1 version of my payment service, and 30% is going to be forwarded to the v2 version. So this is basically a canary release. We are basically splitting the traffic between two versions of my service, right? So we can test a new version before forwarding all the requests, 100% of the requests to the new version. And we could also do a split by header, right? So based on a specific header and a specific value of this header, we can forward the request to a version 1 or a version 2 as well. Okay, but just for demonstration purposes, we're using the weight split here. So I'm just going to cancel this. Okay, so this is basically the configuration of the services, right? So our services are now exposed, right? So we have our Sensedia Service Mesh, we have our host that we configured for our Sensedia Service Mesh right here. This host is using MCLS, right? So I have a postman here just to perform some tests. Okay, let me just zoom a little bit. So yeah, if I try to perform, for example, a get customer by ID, So I'm just using some Postman variables here, but this is the URL of my service mesh. If I try to perform a call for the customer service, you can see that our Postman is going to fail because I didn't configure it to use a certificate, right? So it can perform the handshake with the service mesh, with the communication to the API because we didn't send a valid certificate, right? So I'm just going to configure here my Postman. This will just take a second. So for basically every request, I'm going to use a certificate that I have here. So I just have a valid certificate that the service mesh trusts. Okay. So I'm just going to use the certificate here. And if I send a request now, we can see that we get an error again because, as we mentioned, our services here are also authenticated and authorized, right? So I have to first issue a token in order to call this API. So I have my OAuth flow here. We are using the password flow. Okay, so basically we're sending username, password, client ID, and secret. So if I issue this token, so this is hitting my OpenID provider, okay? And we can use this token to perform the call. I don't have to copy this token because my Postman is already doing the job here for me and setting some variables, okay? So when I perform this call, this variable is already going to be filled with the correct value. So if I try to perform this call again, then we can see that I can perform and hit my backend. Okay, so if I perform, for example, a get account by ID, also hit my backend. If I perform a get payments, for example, get payments by account, we can also hit our backends. Okay, and just for demonstration purposes, I have a second user here. So I'm just going to use the second user that I have configured. And this second user, he doesn't have the permissions, he doesn't have the role to call the payment service, right? So remember that in our service mesh, we configure that in order for a consumer to call the payment service, it has to have a payments role. Okay, so if I perform this call, the get customer is going to work, the get accounts is going to work, but the get payments is going to fail, right? So we're basically using RBAC here, role-based access control, right? So we can perform this call right here, okay? Moving forward and getting close to a finish here, we're going to see also in the API gateway how we can expose our APIs to the external world, but going through the API gateway, right? Because as we saw in our presentation here, all the requests that our consumers are going to perform, they're not going to call directly my service mesh, right? They're going to call my Sensedia API gateway. So we can implement some security in our gateway as well. So how can we configure this? So if we come back to our customer service API, I'm just going to change to the revision 2 here. This is the revision that is deployed in production, right? So this is our production MTLS environment that we are using. And if we get to the flows of the API again, we can see that the flows now are a bit different. We don't have any mocks anymore because we are hitting our backend, in fact. So basically, we have a lot of interceptors here. So we can see that Sensedia is performing a lot of validations before the request gets to our backend. So we have, for example, a rate limit request interceptor that limits our requests, 300 requests per second, for example. We have a log interceptor again, which is going to log every request for us. But before this log interceptor, we can see that we have a log obfuscation interceptor. So basically, we are obfuscating the token that we are receiving because we don't want to see that we don't want to let the token exposed in our logs, in our traces. And we are also obfuscating the body of the request to hide the document and the email that we receive and replace it to stars. Okay. We're going to see this in the trace. This is the OAuth flow. So basically, we are using the OAuth password flow. Okay, so this is the interceptor that performs this validation. So my API is not public anymore. If I try to perform a call to my API gateway, this interceptor is going to validate the request is not authorized or authenticated. Okay. We have a payload size interceptor, which validates if the payload has a maximum amount of size. We have the SQL threat and XSS threat protection interceptors. So these interceptors basically validate if we have any potential SQL injections in our requests and XSS injections in our requests. Okay, so if we see a potential SQL threat, since the API gateway is going to block the request and it's never going to reach our backends. Okay. And this interceptor right here is just a custom interceptor that is basically going to get the token from our OpenID provider to hit our backend. because as we mentioned, this request right here from the gateway to the backend is using MTLS, but it's also using it's also authenticated and authorized. So I have to send a valid OpenID token here from my OpenID provider. So this is basically the interceptor that does the job for us. And we also have another log here to log everything that happened between these two logs. And here we have finally our backend destination, right? So this variable is configured in Sensedia API management. And in this variable, we are telling, when we configure this variable, we told Sensedia API Gateway to use a certificate, right? Because as we saw in Postman, we can't forward requests to my backend without using a valid certificate, right? So Sensedia, when we set up this environment variable, we told Sensedia API Gateway to use a valid certificate, which is the same certificate that I told my Postman to use, okay? So this is basically the request and response flows, right? So in the response, we don't have a lot. We just have a log obfuscation here to obfuscate some information as well from the body, okay? And now let's move on to some requests. So I'm just going to go back to Postman. And I also have to issue a token for this request to work. But now we have a Sensedia token right here, right? So this token is going to be issued within Sensedia authorization server. And Sensedia authorization server is going, remember when I said about this API right here, this identity API. So this API is going to, when Sensedia issues a token for our consumers, this API is going to also issue a token within my OpenID provider and embed this OpenID token provider, this OpenID provider token is going to be embedded inside the Sensedia token as well. So when our consumers perform requests to Sensedia, we can retrieve the OpenID token, right? The OpenID provider token. So I'm just going to issue a token here. And we can see that we have a token. We can see that this token is different from the OpenID provider token because this is a Sensedia token. Okay. And we can now perform some requests. For example, I get a customer by ID, and this is hitting our backend. Account by ID, this is also hitting our backend. ID, payment by account. Okay. We also have some vulnerabilities tests here. So we can see, for example, this SQL injection request. This is a very basic example, but we have a potential SQL injection here. And since it is going to block this request, right? So we get a 400. And also an XSS, a potential XSS attack is going to be blocked, the API gateway as well. Okay. And now we can see the traces in Sensedia API. So if I take this customer service, we see that we have a trace API button here. And we can see that we have a 200 here, which is performed just about now. I'm just going to open this in a new tab. And we can see some basic details of our trace here and also the complete trace of our API. Okay, so we can see everything that Sensedia is performing and also the amount of time that Sensedia is taking to perform each of these steps. So we can see, for example, before the request was forwarded to our backend, Sensedia took only 4 milliseconds to perform all these validations that are here. Log obfuscation, the token validation, SQL threat protection, for example. And we can also see the request log. We can see that the bearer token, for example, is hidden because we obfuscated it. And also in the response, down here we have the response log. We can see that this response is also obfuscated, the document and the email, because of our interceptors. Okay. And just to finish, I just wanted to show a little bit of service mesh observability as well. So I'm just going to, I have a runner here on Postman, which is going to perform a lot of calls. I'm just going to run it. So you're getting a lot of 200s here. And if you take a look at our service mesh here, we have this graph section, and we can basically select our namespace in Cydia Bank. And I'm just going to get the request percentage here. And we can see that we are getting some requests that are coming from our Postman. Just refresh this a little bit. Yeah, so we can see that we are getting a lot of requests, and the account service is also performing requests to the customer service. So we can see that the account service also communicates within east-west communication with our customer service, for example. And here in the payment service, we can also see that the traffic is being split between the two versions. Okay, so the gateway is going, the service mesh is going to try to split this traffic in 70-30% that we saw in the configuration. Okay. So this is a very cool feature. We can see the requests happening real time here. Okay. We also have some tracing here. We can see the requests in more detail, right? So we can see more details of the requests. And we also have we're running out of time, so I'm just gonna show another feature here. Inside our Sensedia, our account service, we also have some metrics here that we can see, for example, for the last 5 minutes, for the last 1 minute, how the requests are behaving. So we have the volume of the requests, the duration of the requests, the request size, the response size. Okay. So this is basically the observability that we get from Sensedia Service Mesh as well. And also in the graph, we could see you could also see the response times here as well. So we can basically see which service is taking longer to respond. So we could, for example, act to make these requests a little bit faster, for example. So yeah, that's pretty much what we had in mind for the demo as well. Torqueto, I don't know if you have anything to add here, if I forgot to mention something.
No, just the final considerations. Just move the presentation. So thank you, guys. Actually, in name of Sensedia, this was the demo that we are intended to present for you today. So thank you, and I hope to see you soon. So feel free to contact us directly. Those are the links for our LinkedIn accounts. And that's it.
Good. We have 3 minutes. I don't know if you have any questions in the chat.
I don't think so.
Yeah. Great. So thanks everyone for joining. I hope you could learn something here with us. So yeah.
Thank you, guys. So just closing the session. And again, if you have any questions or anything, feel free to contact us directly. Thank you. I hope to see you soon.
Thank you. Have a good one.